Now let's go ahead and meet the Takumi and check out his innovative filtration device that makes it easier to provide clean water for those in need. Water is indispensable to our lives. In Japan, you can have safe and clean water from the tap with just a twist. But around the world, there are still many people without access to this kind of water. Today's Takumi has developed a filtration device that could help these people in need. This time, we visited Sakai City in Osaka Prefecture, which has a long history as a trading port.
こんにちは、山本ミシェルです。
こんにちは、なにわ工作者谷本と申します。今日はよろしくお願いします。
よろしくお願いいたします。
Today's Takumi is Kazutaka Tanimoto. He runs a company that mainly manufactures and designs plastic molds. He showed us the filtration device that turns dirty water into clean water.
これですね、こちらです。
これがその装置なんですか？
はい。
This is the filtration device developed by the Takumi. We will do an experiment to see how well it removes impurities.
じゃあ入れます。
The tank on the left contains water with sand and pollutants. A hose is placed into the water and the machine is switched on.
結構勢いありますね。
はい。
The filtered water comes rushing out. It's easy to see that the water is very clean, free of sand and impurities.
おお、すごいんですが綺麗ですね。
It filters about 50 liters of water per minute.
どういう構造になってるんですか？
まずこちらの方に水が入ってきます。そちらからここが水が出ていく方ですね。で、水が入ってきたところに新しい遠心分離技術を使って水を回転をさせながら、汚いものは下に落とします。
The Takumi designed it so that water entering the device is swirled around, which separates out large impurities like sand and debris. The impurities are then discharged beneath the device. In a single day, about 70 tons of water can be filtered. The Takumi succeeded in removing sand and waste using centrifugal separation technology, but he still had a big problem to face. Water sometimes contains a microorganism called Cryptosporidium, which is the cause of an infectious disease in developing countries. This microorganism is just 2 to 5 micrometers in diameter, too small to separate with a centrifuge. Conventional filters use membrane filtration to solve this problem. Here's how it works. In membrane filtration, there are holes that measure 0.1 micrometer in diameter. Water molecules can pass through the holes, but Cryptosporidium that are 2 to 5 micrometers cannot. But membrane filtration is costly and easily clogged, so using it in an underdeveloped country is difficult. To remove the Cryptosporidium at a low cost, the Takumi tried out different materials with different sizes of holes and durability. This is the filter that the Takumi developed, and it has a hidden feature. The diameter of the holes in the filter are 2 micrometers, just the right size to keep out Cryptosporidium. and by making the holes bigger, more water can be filtered. This is the filtration device that the Takumi completed. After making numerous improvements, he designed a filter in the area above the centrifugal separation device. The size is also more compact, and one device costs less than $7,000, which is much cheaper than conventional machines. This filtered water can be used for domestic needs such as bathing and doing the laundry. The Takumi is planning on using this device abroad to tackle problems surrounding water.
我々の方で開発したろ過装置を使ってまずアフリカの方に持っていきたいと思ってます。でアフリカで水を作って安い水を作ってその水をアフリカの人たちが各地に運んでまたそこで仕事が生まれるようなビジョンを持っています。
Today I brought in some water filtered by the Takumi's device, as well as some of the original muddy water to compare.
Wow, so this is before and after. We can clearly see the difference.
The device filters water at an extremely high speed considering its size, and it is easy to set up.
Being easy to use is really important for people in countries without access to clean water.
That's true. The Takumi said he's trying to improve his filtration equipment so that it can be used in more places around the world besides Africa and also support more applications.
Well, I hope it can be used throughout the world. Thank you very much, Michelle. So, Ms. Yamazaki, how would you wrap up today's program?
Today, we explore the mystery of the aurora, which really demonstrates the constant interaction between Earth and space. The aurora is usually greenish in color, but sometimes a mysterious red aurora can be seen. While there is still much we may not know about the aurora, the very fact that we can see it at all is clear evidence of how the Earth's magnetic field protects our planet in the harsh environment of space.
And that's all for this week's Science View.
Thank you for joining us.
And see you all again next time.